Hello everyone and welcome back to Geotech Masters. We have reached a very exciting turning point in our course. In the earlier episodes, we acted like gemologists. We looked closely at the small piece of rock in our hand. We described its color, its grain size, and its strengths. We called this the rock material. But today, we are going to zoom out. We are going to look at the rock mass. In geotechnical engineering, the rock material rarely fails. It is the cracks, the layers, and the breaks between the rock blocks that usually cause problems. In this episode, we'll learn how to describe the large-scale structure of the ground, how to measure bedding thickness, and how to identify the discontinuities that cut through the rock. This is where geology meets engineering design. Let's get started.
Here are the key questions we will answer in this session. First, when we look at a rock face or a borehole log, how do we describe the overall pattern? Is it a solid block, or is it like a stack of pancakes? We call this the structure. Second, we often use words like thinly bedded or thickly bedded. But what do these words actually mean in numbers? We will look at the specific measurements required by the standard. Finally, and this is perhaps the most important skill for a field engineer, when you see a break in the drill core, is it a natural fracture that was already in the ground, or did the drill machine break the rock while extracting it? Knowing the difference between a natural and a mechanical break is critical for your data quality. Let's quickly refresh the concept from our first episode. The standard defines the description of the rock mass. The rock material is the intact rock between the discontinuities. It is what we test in the lab for UCS. The rock mass is the total system. It includes the rock material blocks plus the discontinuities that separate them. Imagine a brick wall. The rock material is the brick. The rock mass is the whole wall, including the mortar joints. The structure is the pattern of these joints. In engineering, water flows through the structure, and slopes slide along the structure. Therefore, describing the mass correctly is often more important than describing the material. Section 6.3 of the standard.